Best teachers पढ़ाए तो simple लगे everything. Leaderboards and quizzes से
Amazing.
learning हो जाए happening. समझ आएगा तो मजा आएगा.
Vedantu, learn live online. To attend a free live class, download the app now.
Hi guys, a very good evening to all of you and welcome back. So guys, I hope all of you liked the questions that we discussed on the chapter probability yesterday. So today we'll be continuing our Killer 5 series with the chapter Matrices and Determinants. Okay, so we will get started in a short while. So for those who are attending for the first time, my name is Shimon Joseph and I'm a maths master teacher here at Vedantu. I've been teaching for almost 5 years now, mentoring over 5,000 amazing students like all of you. And like you guys, I too prepared for JEE Mains, JEE Advanced, KVPY, and I cleared all of them. So guys, if you are here for the first time, let me show you the Killer 5 schedule which is planned for all of you. So right now we are on Matrices and Determinants. We will be continuing with the Killer 5 until January 5th. So please do mark your calendars, and if you're free on Saturday and Sunday at 9 PM, do watch it at that time. Okay? So with that, let's dive right into our first question. Without further ado, let's see what we have in store. So this is the first question which I have brought for you. So if you have P, this matrix, as the adjoint of a 3x3 matrix A and determinant of A is 4, then what is my value of alpha? Okay, this was a question which was asked in JEE Mains 2013, and guys, it's relatively easy. But here there are a few concepts that you have to be aware of. Okay, the first thing you should know is this is the adjoint of A. Okay, so P is nothing but adjoint of A. Let me write that down for you. Okay, you guys can try to solve it along with me. This is a good question, guys. Okay, what do we have now? First information is P is equal to my adjoint of A. After this, I am given det of A is equal to 4. Now guys, what is det of P? Det of P is equal to det of adjoint of A. What is det of adjoint of A? Formula? Any idea, guys? It is nothing but det of A to the power n minus 1. That is the formula for det of adjoint of A. Clear? Please note it down, guys, in case you didn't know. This is important. Okay. So what is det of A? Det of A is 4, na? 4 to the power n minus 1. What is your n? Your n is nothing but your order. Okay. Whenever we are talking about determinants, we talk about square matrices. So if your order is 3 cross 3, then your n is 3. So 3 minus 1 will be how much? 16, na? 4 square. So det of P is equal to 16, and I have P matrix defined here. So can I calculate my determinant? Let's do that. Very simple stuff. So 1 into 3 into 4 minus 3 into 4, which will be 0, minus alpha times of 1 into 4 minus 6. 4 minus 6 plus 3 times of 4 minus 6 again. Isn't that correct, guys? Are you all able to get that? Yes? Perfect. Now let's move forward. What do we get our alpha to be? This determinant is equal to 16, na? So we'll have 2 alpha minus 6 is equal to 16, which implies 2 alpha is equal to 22. So what is my alpha? Alpha is equal to 11. Do we have any option which says 11 as the answer? Yes, I do have an option which says 11, and that will be my answer. Are you all able to understand it, guys? So it was a very simple question to start off with. Let me move this aside. You guys can have a look at the way I have solved it. And there are few key points that you have to take away. What is that? How do you relate adjoint to a matrix A? That is the first thing. And then the relation between det of adjoint of A and det of A. These are the two key points which are spoken about in this question. Okay, perfect. So I'll probably pause for 5 to 6 seconds. You guys can note it down. And with that, let us move forward to the next one. Okay, so let us go ahead, guys. Let's move forward. So this is the solution which is given to you. You guys can go through it later on. The second question is right over here. And guys, let me tell you, you will for sure get one question on this. What is this topic called as? This topic is called as system of linear equations. So usually you will get system of linear equation in 3 variable and you will use something called as Cramer's rule to solve those equations. Clear? So you might have either a homogeneous equation or a non-homogeneous equation. You should be ready to solve both these type of questions, and please do revise your matrices and determinants notes for that. Okay? And if you want to solve a number of questions based on this concept, you can probably check out the JEE sprint video of last year. We discussed a lot of questions on matrices and determinants. Please do check it and solve it. Okay? Now let's try to solve this question. I brought a single one so that you guys realize its importance and go back and redo it more and more. Okay? Let's try to solve this. So here I have to find out the values of x for which my system of linear equation has a non-trivial solution. Guys, they meant values of lambda, it's not x, so please change that. It is not x, it is values of lambda. So here if you look at it carefully, they are asking you system of linear equations which are homogeneous. What do you mean by homogeneous? Homogeneous means your right hand side will not have a constant, rather it will have 0, isn't it? You won't have any other constant apart from 0. So let's try to have a look at it. Let me rewrite it. I can write this as 2 minus lambda times of x1 minus 2x2 plus x3 is equal to 0. And then I will have 2x1 minus 3 plus lambda times x2 plus 2x3 is equal to 0. And then I will have minus x1 plus 2x2 minus lambda x3 is equal to 0. So can you all see that? It is nothing but a system of linear equation which are homogeneous. Now guys, why are they asking non-trivial solution? Because as you all can see and predict, 0, 0, 0 will always satisfy this. That is why it is called as a trivial solution for homogeneous equations. Are you all able to understand that? So if I put x1 0, x2 0 and x3 0, I will get all the 3 equations to be satisfied. Are you all able to get that, guys? Please be very careful, that is an important point. Now, if I want to make sure it has a non-trivial solution, what do? I'll have to make sure the determinant of all the coefficients is equal to 0. That is the condition. If you read textbooks, you will see this condition, del is equal to 0. So if my del is equal to 0, then I will have a non-trivial solution for this. So how do you make sure delta is equal to 0? How do you apply that? Let's try to do that in the form of determinant. I will get 2 minus lambda minus 2, 1. And then I'll have 2 minus 3 minus lambda, 2. And then I'll have minus 1, 2 and minus lambda. This determinant is 0. That is what is given by delta is equal to 0. Clear? Now let me open it and solve for lambda. As simple as that, guys. You just need to open it, solve for lambda. That will give you an answer. Okay. So system of linear equations, very important. Try to learn that. So how do I solve it? Let's do that. I'll open it directly. 2 minus lambda times. What do I have? 3 lambda plus lambda square. So lambda square plus 3 lambda. And then I'll have minus 4. Okay. Then I'll have plus 2 times of minus 2 lambda plus 2. Minus 2 lambda plus 2. And then I'll have plus 1 times of 4 minus of, what will I have? If I multiply these two, I'll have 3 plus lambda minus of 3 minus of lambda. Okay. Now that is equal to 0. I need to solve that. Let's try to do it together, guys. Okay. Please solve it along with me. Very simple question. Let's crack it together. What will this be? This will be 2 minus lambda times. I will factorize this. This will be what? Lambda plus 4 into lambda minus 1 plus 4 times of minus lambda plus 1. And then finally you will have minus lambda minus lambda plus 1. Okay. So you will have plus minus lambda plus 1 is equal to 0. That's it. As simple as that. The reason I factorized is because, guys, if you don't factorize it, you will get a cubic equation which you have to solve by different method now. Okay. I think I have erased the entire thing. Let me rewrite it. So I got 2 minus lambda times of lambda plus 4 lambda minus 1 plus 4 times of 1 minus lambda plus 1 minus lambda is equal to 0. Okay. Now the reason I tried to factorize it is because, guys, if you have a cubic equation, you will have to use synthetic division. You have to first guess one root and then figure out how to reduce it by either synthetic division or long division, which might be time taking task. But if you factorize it directly, you can see that lambda minus 1 is a common factor. So if I take lambda minus 1 common, what do I get? I get 2 minus lambda into lambda plus 4 plus minus 4 plus minus 1 is equal to 0. Is that correct? Now I can open it. I can open the square and then solve it. So lambda equal to 1 is one solution. Let's forget that. I will solve this part alone. What is this part? Can you guys help me open it? So you'll get 2 lambda plus 8 minus lambda square minus 4 lambda minus 5 is equal to 0. So what will I get from here? I'll get lambda square. If I take it to the other side, then I'll get plus 2 lambda. Then what will I get? I'll get 8 minus 5, which will be 3. If it comes this side, it will be minus 3 equal to 0. So this will factorize at lambda plus 3 into lambda minus 1 equal to 0, which will be giving roots as 1 and 3. So 1 and 3 are lambda values from here, and from here you got lambda equal to 1. So what are the solutions? You have 1, 1 and 3. So the set of values for which this system will have a non-trivial solution. The set of values of lambda for which this will have a non-trivial solution will be 1 and 2. It just contains 1 and 3. So the set of values of lambda for which the system of linear equations contains a non-trivial solution will be 1 and 3 alone, because in a set you don't repeat elements. 1, 1, 3 we got, but we don't repeat elements now. So you'll have only 1 and 3. Therefore, answer is contains 2 elements. That will be the right one. I hope you guys learned something useful from here. With that, let's move forward, guys. It's a very simple concept. So when you have a homogeneous linear equation system, just make sure delta is 0 for non-trivial solution. For trivial solution, obviously they won't ask questions based on that, because anyway trivial solution is known. And for a non-homogeneous system, there are methods to solve it, which we have discussed in detail in JEE Mains Sprint. So please go through with that, guys. Okay. So I'll pause for probably 5 to 10 seconds, note it down, and with that, let's move forward to the next one. Okay. Perfect. Let us go ahead, guys. Let's go to the next question. The next question for you all is right over here. Now we have to calculate the value of this determinant. Pretty simple, because in sequence and series you might have learned this property. When A1, A2, A3, AN are in GP, log of A1, A2, A3, if you take the log of everything, they will be in AP. Isn't that correct? I'm sure you guys must be aware of that, right? So I'm going to use something like that. Let me first reiterate what I said so that you guys will understand what's happening. So guys, let's say A1, A2 till AN are in GP. So can I write them as A, AR and all the way up to AR power n minus 1? This is in GP, na? We all know that. I'm just writing them in this fashion. Now let me take log in all the terms. So I'll take log of A, I'll take log of AR, and I'll take all the way up to log of AR power n minus 1. Now can I write it as log A? This one I can write it as log A plus R, and the next term I can write it as log A plus 2 log R, and all the way up to log A plus n minus 1 log R. So do you guys agree that this is an AP? Why is this an AP? Because your first term and second term have an addition of log R. I'm sorry, this will be log R. Okay, and second term and third term also you see an addition of log R. Log R is getting added to each and every term. So that is why I will call this an AP. Are you guys clear? Perfect. So now With that, let's try to come and tackle this question over here. So what do we do over here? Any idea? So guys, what I'm going to do is I will write column 2 as column 2 minus column 1, and column 3 I will write it as column 3 minus column 2. What will happen here? Let's do it and see. So first I'll do this step, which will give me what? Which will give me log an plus 3 log an plus 6, and then here I'll have log an plus 1 log an plus 4, and then you'll have log an plus 7. Here I'm doing this as a first step. Now this is my first step. So C3 minus C2. So C3 minus C2. Log an plus 2 minus log an plus 1. That will be what? Log of an plus 2 by log an plus 1. Let me write it down for you. It will be log an plus 2 minus log of an plus 1, which will be log of an plus 2 by an plus 1, which will be what? Log of r, na? Which will be log of r. Are you guys able to understand that? Clear? That will be log of r. Why? These two are consecutive terms of a GP, so their ratio will be common ratio. That's it. So this will be r with the log outside. Okay. Similarly, an plus 5, an plus 4. This will also be log r then. Isn't that correct? Here also, log of an plus 8 minus log of an plus 7, which will be log of an plus 8 by an plus 7, which will be log of r. Getting it, guys? That's it. I hope all of you are able to understand it. Now, with that, let me do the second step. This is my second step. So if I do the second step, what will I get? I'll get column 2 to be column 2 minus column 1. So log of an plus 1 minus log of an, which will be log of r. Similarly, log of r. Similarly, log of r. And column 3 also is log of r. Log of r and log of r. Column 1 will be what? The same thing. Log an plus 3 and log of an plus 6. Answer will be 0. Why the answer will be 0? Because two columns are identical. If two columns are identical, then the value of the determinant is 0. I'm sure you guys are aware of that property. So this is how you solve this question, all coming from your knowledge of sequence and series. So guys, you need to be really strong in sequence and series because it's a very simple chapter and has very good applications in other parts of maths as well. Okay. So here I tried to use the concept, if you have a geometric progression and if I take log to each and every term, assuming that they are positive, then I will be ending up with an AP. Clear? That is the property that I tried to exploit. Since I knew that, I knew if I subtract any two consecutive terms, I'll get a constant log r. Getting it? That's how I solved it. So please go through it and let me know if you have any doubts. I'll probably give you some 5 to 6 seconds to note it down. And with that, let's move forward. Let's see what is the next question that I have in store. Okay. So yeah, let's go ahead, guys. Let's go to the next question. The next question for all of you is right over here. This is a very good question which was asked in the year 2012. Let's try to solve this. Okay. So here we have P and Q as two 3 cross 3 matrices where my P is not equal to Q. And it is given that P cube is equal to Q cube. Okay. And P square Q is equal to Q square P. Then I want to find the value of this determinant. Okay. Let's do that slowly. This is a good question, guys. So what I'll do first is I want to make use of this expression and this expression. I want to make use of it together. At the same time, I want to keep in mind that I'm interested in finding this. So what can we do? So guys, if you multiply P square plus Q square along with P minus Q, what do you get? We will get P cube minus P square Q plus Q square P minus Q cube. This is what you will get as the expansion. Are you all able to understand that? Direct multiplication. P square into P will be P cube. P square into minus Q will be minus P square Q. In matrix multiplication, you have to maintain the order, guys. Okay. Because commutative law does not apply to matrix multiplication. What does that mean? That means AB in matrices does not mean BA. Okay. So please be very careful about that. Now, I know that P cube is equal to Q cube. So can I cancel these two? They will give me the null matrix. Because if I bring it to the other side, P cube minus Q cube, I'll get the null matrix. And guys, please don't think that is an equation in terms of values. It is an equation in matrices. Please remember that, because it is not determinant. It is the matrix cube equal to matrix cube. So when I bring it to the other side, I'll get null matrix. So here again, P square Q is equal to Q square P. So when I subtract both of them, again I'll get null matrix. So my right hand side is a null matrix, guys. Okay. Now I have P square plus Q square, which is a 3 cross 3 matrix, and P minus Q, which is also a 3 cross 3 matrix. When they are of same order, I can apply determinant to the whole thing. What will I get? Right hand side is 0 because determinant of a null matrix is 0 only. And left hand side, I can split it as determinant of P square plus Q square into determinant of P minus Q equal to 0. Are you all able to understand that? Clear, guys? Now we are interested in this one. And please let me reiterate, only if they are of same order you can do this. Only if they are of same order you can do this. Otherwise, please don't try doing this. It is wrong. Okay. Now I am interested in this. Okay. So first, let us assume that this determinant value is non-zero. Okay. So let me say my det of P square plus Q square is not 0. I am assuming that. So if this is not 0, then this is a non-singular matrix, P square plus Q square. Are you all able to understand? So I want to write some space I need. Let me probably erase this. Okay. So if determinant of P square plus Q square is not equal to 0, then P square plus Q square is a non-singular matrix. That means it is invertible. So every non-singular matrix will be invertible. Only when the determinant becomes 0, it will not be invertible, because your matrix will then become singular. Singular means determinant is 0, guys. Okay. So here, if it is invertible, can I take this equation? Can I take this equation and do something magical here? Let's try to do that, guys, together. Okay. So let me do that quickly and see how to solve this question. So here, I know my right hand side is 0. Let me erase my right hand side. My right hand side is 0. Okay. That is null matrix. So since I assume this is not 0, my P square plus Q square is invertible. That means I can multiply by P square plus Q square whole inverse to the both sides of the equation. I am pre-multiplying by P square plus Q square whole inverse to both sides of the equation, because it is an invertible matrix. So right side will be 0, because 0 matrix multiplied with anything is 0 only. We know that already. But my left side, these two will give me I into P minus Q is null matrix, which means P minus Q is null matrix, which means P is equal to Q. But wait a minute, in the question they told me P is not equal to Q. But here I am getting P equal to Q. That means what I assumed is a contradiction. Therefore, determinant of P square plus Q square is not 0 is not true. If that is not true, then what is the determinant of P square plus Q square? It has to be 0. That is how you solve it. It's a very nice question, guys. Okay. I hope all of you liked it. And if you have any difficulty, do let me know. I try to explain it as elaborate as possible. But if you have any questions, do post it down in the comments. Okay, I'll give you some time, please copy it down, and with that let's move forward. Let's go to the next question that I have for you. We are going to finish on a high note, so I have a very power packed question for you. Next one. Okay, so yeah, let's move ahead. The next question for all of you is right over here, guys. This is the next question. This was asked in the year JEE Advanced 2016 it was asked. Let's see how to solve this question. It's a good one. Okay, so what did they do here? They gave you a matrix P, and I is identity matrix of order 3, and then you have another matrix Q, which is such a way that it is nothing but a matrix satisfying this equation. So if I want to find Q, I first need to find out what is P power 50. Isn't that correct, guys? Because what are they asking? They are not asking what is determinant of Q or what is the size of Q or something like that. No easy questions asked. They are asking questions on the elements of Q. So here you can't escape. You have to find out the matrix Q and then figure out the element Q31. What is small q? Many of you might be wondering, sir, what is small q? Small q is nothing but the elements of the matrix Q. So Q31 means it is the element present in third row and first column of my matrix Q. Getting it? It is the element present in third row and first column. This will be what? Third row and second column. Second row and first column. Okay? That is what we have to figure out. So ultimately, all of us, I hope, are on the same page. We need to find out Q. That is our task. I need to find out the matrix Q. Let's see how we can do that. For that, I need to first evaluate what is P power 50. And guys, look at the numbers. Can we evaluate P power 50? It will be huge, na? But there is a short way to do this. Let's see how we can simplify it. Okay? And guys, this is a very powerful method. So please try to learn it and use it in your exams. Okay? So what I will do is, I will write P like this, guys. Can I write P as 1 0 0 0 1 0 0 0 1 plus 0 4 16 4 0 0 0 0 0. Can I write it like this? Are you all happy with that? Because if I add both these matrices, I will get the exact same thing. 1 0 0 4 1 0 16 4 1. Absolutely right. No problem. Now this is nothing but equal to I plus, let me call this matrix as some A. So can I call this as I plus A? Are you all happy with that? So this P, I am writing it as I plus A. It has huge benefits, guys. I will come to that. I'm sure some of you would have realized it by now. What am I going to do? The reason I represented it like this because I want to use binomial theorem. Okay, so when I raise it to the power 50, I will have I plus A to the power 50, which can be evaluated because of a magic which is going to happen. Okay, please watch carefully. So if I do P power 50, it is nothing but I plus A to the power 50, which is what? Which is 50 I plus 50C. What will you have? We'll have I to the power 50, right? 50C0. Let's do binomial theorem expansion, guys. What is that? 50C0 I to the power 50, which will be I only, plus 50C1 I to the power 49 into A to the power 1 plus 50C2 A square and all the way up to 50C50 A power 50. Now you might ask me, sir, what is the benefit of writing this, sir? Anyway, you have to calculate A power 50, na? Look at A, sir. Such a big matrix, you have 4, 16, 4 and all. How can you even evaluate A power 50? What is the benefit of this method? It will all make sense when you give it a try. You have to first figure out what happens to A when you keep squaring, cubing and increasing its power. Look at this, guys. So many zeros are there, na? Naturally, when I square A, I'm going to introduce more zeros. And when I cube A, the matrix will almost vanish. That is what I'm going to show you. I hope you guys have taken it down. Did you all understand it till here? What is the method I'm trying to use? I'm trying to split the matrix P as identity plus something else. which has a lot of zeros. And then when I raise it to higher powers, I will get a binomial expansion like this, which has higher powers of a. But don't get disheartened. It is not yet done because you still didn't figure out what are the higher powers of a, na? Let's do that. Okay, please note it down. I'm going to switch to the next slide because I have already brought it ready-made. Because a powers, I don't want to write it by multiplying. It will take a lot of time. So I have brought it ready-made, guys. So these are the powers of a. I hope you guys noted it down. A is nothing but 0, 4, 16, 0, 0, 4, 0, 0, 0. When I square it, you see more zeros are coming. When I cube it, it becomes null matrix. So what is all the matrix coming after this? All the matrix coming after a cube, that is a power 4, a power 5, a power 6, all the way to a power 50, everything is 0. So now what will happen to my p to the power 50? My p to the power 50 will be I plus 50a plus 50c2 a square. That's it. Everything apart from that will be 0. Why is it 0? Because I know that a cube onwards, my matrix becomes null matrix. That's it. That is the beauty of this question, guys. Okay. Now what is p power 50? P power 50 is q plus I. So let me write this as, let me erase this p power 50 and write it as q plus I. This I and this I will get cancelled. So what is my q? My q is 50 times a matrix, which is 0, 4, 16, 0, 0, 4, 0, 0, 0. That is my q matrix plus 50c2. What is 50c2? 50 factorial by 48 factorial into 2 factorial, which will be 49 into 50 by 2, which will be 25 into 49 into a square will be what? 0, 0, 0, 0, 0, 0, 0 and 0, 16. So now what is Q31? Q31 will be this term plus this term. But wait a minute, don't forget the outside scalar that is being multiplied. So Q31 will be 50 into 16 plus 25 into 49 into 16. That is Q31 plus Q32 will be 50 into 4 plus 0 over here. Because third row second element is this one and this one. So 50 into 4 alone will be there. So you'll have 50 into 4 divided by Q21. What is Q21? Q21 is nothing but second row first element. So 50 into 4, there again is 0. So you'll have by 50 into 4. So when you solve it, what do you get, guys? Let me solve it for you. You will get first 4 plus 51 by 2, 8, 2, 98. 98 plus this is also 1. So you'll have 103 as the answer. Okay, 103, is it there? Yes. That is how you solve it. Very nice question, right? So very beautiful method. And guys, let me tell you, you will have a lot of questions like this. Okay, wherein higher powers are asked. And when you want to simplify those higher powers, either you have to find a pattern, look for patterns, or do it by this method. This is a very standard approach, easily solvable, and kindly note it down, guys. Okay. So that was the last question for the session. I hope you guys are learning something useful, and please put in your effort, guys. As I always say, your effort matters more than what we do over here. I can only expose you to concepts, but please try to use it in other questions. Okay. So yeah, let's conclude our session with that. So these are the solutions. If you guys are interested, do download the session PDF and go through them. And with that, let's conclude our session. And if you guys are interested in the crash course, please do check it out. It is available for a very reasonable price of 8,000. It is almost about to end. But yeah, you guys can make use of it. If you are interested in an intensive course, you have all the recordings of all chapters. You can make use of it. As usual, do like, share, subscribe and comment down what you felt. And if you want anything in special, or if you want a particular topic to be covered, do let me know. I'll try to see what best can be done. Okay. And guys, all the very best. Keep working hard and try to solve as many questions as possible, because math is a subject wherein your exposure matters a lot. Try to solve all the previous year's questions and JEE Advanced integer type questions and one single choice correct questions, all that you try to solve it. That will give you a good edge over others if you are aiming for a very good score, let's say above 80 or 90 in maths. Okay, and yes, do let me know what you felt. Till then, take care, bye bye, and let's see you in the next one.